So let's say you're given the scenario where we have a object traveling 5 meters per second, and they say if this object has no net force acting on it, what will its velocity be at t equals 10 seconds? To answer this question, we need to know Newton's first law, which states that an object acted upon by no external net force has a constant velocity which may or may not be zero and zero acceleration. But what does this actually mean? This can be illustrated by taking examples. So let's take an example of pushing hockey pucks on various objects. So we can start by pushing it on a table. Push this hockey puck on the table. It's going to move slightly and then it's going to come to rest pretty quickly due to the friction force of the table. But if we take the same hockey puck and push it on the ice, the puck will come to rest much later. This is because in both cases, the reason the puck is not continuing to travel at a constant velocity from the push is due to an external force, which is friction. As we can see in the table, there's a friction force acting opposite to the velocity. The same force is acting on the hockey puck in the ice scenario, but the friction force has less magnitude, so it moves it slower. Thus, in this case, if there's no friction on the puck would just continue to travel forever, which proves Newton's first law. You can look back to our example here, and since there is no external force acting on the object between t equals 0 and t equals 2 seconds, from Newton's first law, the object will still be traveling at 5 meters per second and continue to travel at that speed forever.